Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at embedding data within your application. Today we're going to be looking at storing data or information within your application. There may well be parts of your application that require some information which will not change during the session that the application is actually running. This data is effectively hard-coded within the application itself, and we're going to look at several different ways this could be done. You can, of course, create a local variable within any of your functions or subroutines, and then populate that local variable with a string of data. As you have declared a variable, as the name suggests, this could in theory change during the run of your application, if your code will allow that. But effectively here in code, we have hard-coded the value of ABCD into this data variable. This variable can then be used within this function. It could even be passed to other functions or subroutines. However, if this value is to appear in several different places, it's probably more efficient to put this value into a constant. There are two main types of constants. We can have numeric constants and string constants. Here we are declaring a numeric constant at the beginning of the application. Constants should be declared outside your functions and subroutines. So the top of your application code is the ideal place to put them. Here we have declared a numeric constant called max users and given it the value of 30. The percentage sign at the beginning of the name of this constant instructs PowerBasic that this is indeed a constant. And at compilation time, PowerBasic will sweep through the application and replace every reference of the max user's name with the value 30. Therefore, this value cannot change during the run of your application. So for example, if we wish to print out the number of maximum users to our log, we would use this construct. We're turning max users into a string using the format $command. If we ran our application now, we would see max users equals 30. So we have successfully set up a constant value, which is numeric, and printed this out to our log. We can also do the same for string constants. Again, these should be set up at the beginning of your application outside your functions or subroutines. Preceding the name of our constant with the $sign indicates to PowerBasic that this is going to contain a string. In this case, we're populating it with the word finance. And as we did before, we can print this out to our log. As it's already a string, we don't need the format $command. As with the numeric constants, any reference to the $department constant will be replaced with the actual string at compilation time. So if we ran the application now, it would print out the word finance after department equals. So you can set up a number of constants, either string or numeric, at the beginning of your application. The main advantage in this, you may well have 50 references to max users spread throughout your entire application. Just changing the one line max users equals 30 to change it to a different value and compiling your application will change it throughout the whole of your application. So what other ways do we have of setting up constants? PowerBasic also has the macro command. The macro command is very flexible, but its simplest form can be used like this. We're setting up a macro called pi, and we're giving it a value, followed by the 2 hashes, which gives us a large number of decimal places, and preceding the name of our macro with M, just to indicate, for my own reference, that this is indeed a macro. And this macro can be used anywhere within the application. So how would we use this macro within our application? Let's for the moment create a local variable called diameter. We will set the diameter to the value 10. And we're going to work out what the circumference of our circle is by calling a new function called getCircleCircumference, giving it a single parameter, which is the diameter. And in our new function, taking its single parameter, there's only one line of code. And in that line of code, we're taking the macro of pi, multiplying it by the diameter, returning that as a string to the calling function. So if we run our application now, we get a value for the circle's circumference to a large number of decimal places. So this macro of pi can be used anywhere within your application. In this particular function, we're returning a value as a string, but we could quite easily return it as either a single or a double numeric value. Macros, of course, can do a great deal more than just this single line macro. But for the purposes of today's video, that's as far as we're going to use macros. Next, we're going to try using the data command. So we will create a new function to return a list of departments. And this function will take no parameters. So how are we going to use this function to return a list of departments? So here is our new function. We have two data commands. The first data command, finance, marketing, HR, and IT. The second data command is taking a single string, facilities. You can split your data up into multiple data lines, or put it all in a single data line. So we're going to use a for next loop to read through each element within this list of data. And we've declared a couple of local variables to allow us to do this. Item is going to be used for the element number, and list is going to be a string to contain the list of departments. We're using the data count command to return the number of items in the data list. In this case, that value would be 5. You can, of course, hard code this value, but there's no need, as the data count command works quite nicely. So for each iteration of the for next loop, we're using the read $ command. It takes a single parameter, which is the element number of the data list. So we're performing this between the values 1 and 5. So the first attempt to read the data will read the string finance. It will add this to the list variable, and we're adding onto it a semicolon. You could, of course, have a carriage return line feed or any other delimiter of your choice. Once the for next loop has completed, we're returning the list variable to the calling function. So if we try running this now, we will see we have our list of data: finance, marketing, HR, IT, and facilities. So having strings or numbers held within your data commands does give you the ability to hard code your information within the application. Information held within these data lines of code will only be accessible within the current function or subroutine. However, this doesn't stop you populating things like variables or arrays and passing back to calling functions or subroutines. So what if you want more information held within your application? You could, of course, read information in from an external file. That would have the advantage in that if you need to change the information, you don't have to change your application. It would, however, have the disadvantage in that anyone who could actually access your executable would be able to see the file and the information held within it. And if they had write access to that folder, they could amend the file. This may or may not be functionality you wish within your application. So first, let's create a file that we can read into the application, and then we will compare that to an embedded file. Here we have the folder containing our executable, and we're going to paste in a data file. And this data file has 5 lines of data in it, containing a list of vehicle models. So we're going to read these 5 pieces of information into our application. So let's create a function to perform that. So we're going to create a function called getCarListFromFile, passing it a single parameter, which is the name of the file, data.txt. And this new function will return a string, which we will print out to our log. So let's now go and create this new function. So here is the skeleton of our new function taking its single input parameter, which is the name of the file we wish to load. We've created a number of local variables to allow us to process this file. One for a file handle, one for a count of the number of records within the file, another string variable for the list of cars returned from inside the file, another one for the item number being read, and one for the string of the item number being read from the file. So first we will use the free file command to obtain the next available file handle. And we're going to embed the attempt to open the file in a try-catch block. This will ensure, should there be any problem reading the file, we can handle and trap the errors. First of all, we're opening the file for input. I'm using $path$ to embed the string, which is the path to our current executable. We're adding on to that the name of the file. This gives us a full path to the file itself, and our input is being opened as the file handle we have just created. We can then use the file scan command to scan the number of records within the file. This populates the record count variable. So that should return a value of 5. File scan works as it looks for the number of carriage return line feeds within your file, as it expects each row to have a carriage return line feed at the end of the row. So we're then using a for next loop to loop through each record within our file, and then using the line input command to populate the item string variable with the value it finds on the current row. And we're then building up the list of values in the list variable, delimiting them with a pipe character. And once we've got to the end of the for next loop, we're using a function call to return that value to the calling function. And I'm using the trim $ command to trim the last pipe character off the value. And in the finally section, we're closing down access to the file. And should there be any errors with reading the file, we can put code in the catch section to trap any errors and report them back to either the system or the user. So let's try running the application now to see if we get our list of cars coming in. And there is our list of cars delimited with the pipe character. So now that we've successfully read a file from disk into the application, can we take a file and embed it in the application itself so that it does not need to read from a file? Let's create a second file to allow us to do this. I've created a second file called newdata.txt. If we compare the two files, the old file at the top and the new file at the bottom, we'll see they are similar but not identical. In the new file, we have a different vehicle as the last record. This will allow us to tell the difference between the two files. So how would we embed this second file within our application? We can do this quite easily with a single line of code at the beginning of the application, and that is making use of the resource command. The resource command can embed data or information within your application, which you can call on later. We're using the resource RCDATA command. If we have a look in the Windows help file that ships with PowerBasic, we'll see there are a number of commands associated with resource. You can store bitmaps, icons, manifests, strings, WAV files, and version information. In this case, we're using RCDATA. The RCDATA resource contains raw data of any type. It is stored identically to the format it was brought in from the file. So this could be absolutely anything. It could be strings, it could be numbers, or it could be a combination of both. When you compile this application, PowerBasic will take the contents of the newdata.txt file and embed it as a resource within the application itself. This means when you pass your compiled executable file out for release, you do not have to pass the newdata.txt file with it, because it already exists within the executable itself. So how do we access the data in the resource? Let's create a new function whose job it will be to do that. So we're going to create a new function called getCarList from resource, and we're passing it a single parameter, in this case the car data. Car data is the second parameter in the resource RCDATA command. This is a string identifier. You can use either string identifiers or numeric identifiers in your resources. In the resource RCDATA command, the string identifier is not wrapped in double quotes. However, when we reference it within code, you will have to put double quotes around it. So let's create this new function to get the information out of a resource. And here is our new function, taking its single string parameter, which is the resource ID. We're then declaring a local variable called list. And in a single line of code, using the resource $command with its two parameters, the first saying RCDATA to indicate to PowerBasic that the information we're pulling out of this resource is RCDATA information. And we're giving it its resource ID. This single line of code will then populate our string variable, list, with the value of whatever was in that RCDATA resource. So that will pull in from the file exactly what was in the file. As you'll remember from the new data file, if we look at it once more, the content of this file is 5 lines of data. At the end of each line is a carriage return line feed. So our list variable will look exactly like this does on screen. So in order to compare that with the list we took from the file, we're going to put this with pipe delimiters. So we're going to use the replace command to replace any carriage return line feeds with a pipe character in this variable. And that's the variable we will return to our calling function. So if we run the application now, you'll see we have a new list of cars, which matches the first list of cars except for the very last entry, which is a different model, which proves we're getting the data from the resource. So to prove this is not sneakily getting information from the file itself, let's go back and rename our file. So we've already compiled our executable, so the file should be embedded within that. If we change new data, so that it is no longer called new data, and we run the executable again, it will still display the list of new cars as the file was compiled into the executable. So this proves that when you roll your compiled executable out to the users, you do not need to include this file, as it is already embedded within the resource. Of course, you can include multiple files in the resource area using the RCDATA command. And this gives you the advantage of embedding your files within the application. And as long as the content of these files do not need to change, your application will work quite happily. So in summary, what we've done today is look at how information can be stored within your application by embedding it. We have looked at string and numeric constants. We have also looked at using macros for setting up numeric constants. And additionally, we've looked at the resource RCDATA command to take a file and embed it inside the executable itself, allowing you to extract it at runtime and saving you the task of rolling the file out with the executable. Therefore, all your information is held within one application file. Hopefully, you'll find these techniques useful in your applications, but that's it for today. Thank you for watching.